Okay, so I'm Thorsteinn Rögnvaldsson. It's Icelandic, impossible to pronounce for anyone who is not born in Iceland. So everyone calls me Denny. And I'm here together with Jesper, who is over there. So any technical questions on how do you implement this? How do you run this? How much time does it take? And where did you see the problems? Ask Jesper. So I'm only here to sort of show what are the results that we've done. And it's about synthetic data, how you can generate data that you could use to actually train these systems that you then use here. Let's see if this works. Oh, okay. So I don't see the notes here, so I'll have to turn over a bit. So what is the data that we have? We have a data set of buses over 5 years. There's 19 buses in the Swedish municipality, Kungsbacka kommun, not very far from Gothenburg. And it's actually the result of projects that we were discussing together with Volvo in 2005, just to go 20 years back in time, when we said, okay, so why don't we start looking at data on board the buses and do some processing on board the buses, that we can actually share the results of that processing on board the buses and move them possibly centrally, but not send the data itself. We didn't call it edge processing. It hadn't been invented at that time. We should have said, I know Slavomir often says that we should have been first with that name. And so we had a small project, pilot project with them, and then we got a bigger project that actually started in 2009. And therefore, we actually have data 2010, 2011 to 2016, almost 50. It's about 5 years of data of 19 buses. And Slavomir here, who's now a professor at Halmstad University, he was not a professor at the time, so therefore we could force him to bike to the buses and actually pick out the data and the log data. So there's a lot of manual work to get this done once many years ago. It's CAN data, so it's about 100 signals that we collected. It's about 1 hertz that we collected. It's GPS, fuel rate, brake pedal position, and so on. You name it, and we almost have it. And we had several faults observed during those 5 years, because we were interested in, can we actually detect things changing on board the buses and then start reasoning, why are they changing? So can we actually say that this is some predictive maintenance need? The idea was that you shouldn't start out the project with thinking, what is everything that can happen to a bus? Because lots of the things that you think can happen to a bus never happens to a bus. So you actually spend a lot of resources thinking about things that never happen. Of course, if the brakes don't work, it's very important. So you certainly have to think about it in some cases, but in many cases you think about things that actually never happen. And then you find out that there's a lot of other things that happen that you didn't think about that actually are creating problems for your bus fleet. And you should actually be acting on them as soon as possible. The problem with this data, it's great because we can use it. We use it in our research, and it's been used in, I think, in many of the demos that you see today. We can sort of live create a streaming scenario. But we didn't actually write an agreement on sharing that data publicly afterwards. We collected the data, we can use it for ourselves, but we don't share that data. And that's a problem because, of course, you would like to involve more people thinking about open innovation. But then the question is, why can't you share it? Well, it's not the privacy issues, because a bus stops at a bus stop. There's no surprise in that. You're not giving away anyone's home address. But there are market issues in the sense that the bus company might not want to tell anyone else how often their buses break, not to speak of the bus manufacturer that might not want anyone to know how often the buses break. And how many spare buses they need to be able to run their operation and things like that. So if you just share the data straight off, you can actually get quite a lot of information about the operation of a bus, which might not be so good to share. So why do we then work with synthetic data? Well, clearly to share data for cooperation, and we can share that without this business information. And we could also imagine if we have a way to create synthetic data, we could create data that we don't have that much of. It's a wet dream, of course. You say, okay, let's suppose that we have some type of fault which we see only once in 5 years on 20 buses. it's a really serious fault, but we only see it once because it's not very common. But we would like to be able to have an algorithm to detect that, and we know that only have one case. It's not that much. Would we be able to generate some variations on that with the synthetic data, or only if we see them four times? That's also, still not very much. So we could more balance the data for the training. And we could generate more data. We could say that Kungsbacka is not the world's biggest municipality. Halmstad is bigger, where I am from, but still Gothenburg is even bigger. So you could imagine with Kungsbacka data, could we upsample that and say that, okay, if you go to Halmstad, what would the bus traffic be? Or if you go to an even bigger, like Helsingborg, it's not that much bigger, but it's a bit bigger. And say, would the bus traffic be the same, or how much would you have? So here's a figure just showing an example. It's 1 day of driving, and thanks to Jan Tao, who is over there, who actually made this slide. I stole it without any regret from you, of showing you have the bus depot. This is inside Kungsbacka, where the buses stay overnight. And there's lots of data from that particular location. And then they go out and they typically drive up to the station or Resecentrum in Kungsbacka, and then they pick up their passengers. And then they actually, this particular bus company had the, what you would call the trips that went outside of central Kungsbacka, to Särö and places like that. So a typical case for one bus in a day. Now, with this, we did a lot of manual work collection or data collection. I did that. Slaughter picked up the onboard data. I went through the service records for 19 buses for 5 years. And I discovered a lot about service records. One is that they're not very accurate. They are made for different purposes. But we did actually try to collect what I would call metadata for these buses, saying, okay, so what actually happened to these buses? What's the story for each bus? You can imagine, like with a person, when you go to the doctor, they would like to know what's happened to you before. It might tell them something about what's happening to you today. And the same thing is actually true for buses. Just to give you an example of one bus here. So this was in September 2011 when we started collecting the data. We didn't see, well, we actually did see some strange things. And we asked some experts at Volvo, why do we see these strange things? And they said, there's probably something wrong with your logging system. It turned out that was not the case. It complained about gearbox problems, so you can see that actually in the, well, we looked at both the service records, but they also have a log at the bus company. So the bus drivers, every day, they write in the log what happened today, or is there something I have to comment about the bus. So gearbox problems in November, coolant system leak December, problems with the heater, the cabin heater for the buses in December and January. It typically is not a problem that you see in the summer because you don't use it. There was some kind of tampering with the EBS system. So the Volvo Action Service had to go out and fix that. There was an oil pressure problems, might actually mark a possible problems. Then there are some complaints that the engine runs strangely. Okay. Not expected from a Volvo bus. So, but they looked through it and say, okay, it's probably the charged air cooler. So we said, there was probably something wrong with the charged air cooler. So we fixed it, and now it's fine. This was in April in 2012. And then it goes into it goes into service because every bus needs to go through an annual inspection, like every other car or every other vehicle. And you have to pass that. It doesn't look good for the bus company if the buses don't pass the annual inspection. So you always put them into a service for the annual inspection where you go through everything that the annual inspection checks. And then it goes into the annual inspection. And during the annual inspection, the engine breaks down. It's a complete engine failure. You have water coolant pouring out all over the system because one of the cylinders actually breaks up. It's overheated, so just as poof. And when you look at the data, what we were asking for, what was the deviation in the beginning? Well, this engine is too warm. And they say, that's probably something wrong with your logging system. There's a calibration that's wrong. And there's the old pressure problem. So it actually is quite clear that you could see these signs that it was not getting enough lubrication. It was just a matter of time before it was going to break down. And you could have seen this 6 months in advance if you had known what you were looking for. Then they fixed that. It was away from traffic for a month, because every time you have an unexpected failure, it really takes a long time to fix, because you have to take it off and then, okay, this is a complete engine overhaul. Just to give you some feeling for, okay, does this data contain as examples, and what you could possibly do with it. So what did we then do to generate this synthetic data? Well, we went for diffusion models. You've probably all heard of stable diffusion. Everyone has seen these fantastic pictures that you can generate with stable diffusion. And we used the same idea. It's not that we did the coding. We actually found a paper from NIPS in 2023 by a Chinese group. Actually said, okay, so we actually can generate artificial synthetic GPS traces for traffic inside a city. And they used Xi'an city and another city where they actually showed that they could generate this. And we thought, okay, why don't we use that and try? So I actually think that Jesper might have been the one, it's either me or you, who found that article and said, okay, let's try doing this. And then Jesper went into his computer mode. And I don't know if it took 1 or 2 weeks. It's okay, I think I have worked this out. So what the diffusion model does, just to give you sort of an intro, in case you don't know what it is, it starts with the real data, and then it learns how to transform the real data into noise, just destroying that data. But it learns that transform over many, many, many steps, moving from a nice picture into a completely random noise, or Myrornas-krig, as we would have called it, if we were growing up in Sweden in the 70s and we happened to turn on the one channel that we had at the wrong time. Once you've learned that mapping, you actually learn the reverse mapping. How can I go from completely random points to a nice picture? It's the same picture. So you can then start from just that random, and you actually work your way up and you say, okay, I have now a very nice picture of all the traffic in the city. That's the diffusion model. It's really simple to say what it is. It's really a lot of complicated math that goes into doing this. And what they did, this group actually in 2024, it was not NeurIPS, that was KDD. They came with a control trial modification to this algorithm, where they said that, okay, if you had one city, you could possibly go to another city. The only thing you need is the street layout. So you can lock those paths to the street layout. You can generate synthetic data for a new city where you don't have data from before. And we set out to do that. We actually didn't make that for the demo, so you're not going to see us going to another city, but I'm going to show you how it works for Kungsbacka. So the training data looks like this. Just to illustrate to you, different colors here are different trips, so we have to split it up into trips just to make the whole thing feasible to run. And again, any technical questions are directed at Jesper. So here are some stretches of roads that actually are trips. And if you look at the real data, you can see that even real data has problems, because clearly there's no road there. But if you have GPS data, it's not really always correct. So you, of course, have to do some cleaning of your data. Otherwise, you're going to be training for some trips that happen in the ocean. And then once you've trained the model, then you start working it backwards. So you take your inverse model that takes the random data and creates a picture. So this is just a movie showing how you start from the random data. And Jesper has been running several steps here, collecting them all and creating a little movie, so you can actually see what's happening. And I think that's pretty magic. Of course, there's probably even more magic with the stable diffusion that creates very nice pictures, because this is just a road map. But I like it. And then if you would map them onto the map, you see, okay, so this is when the model has been trained on 1 million data points. I think, remind me, yes, but this is one bus for some period, 1 year or?
It's a bunch of samples that scans.
Okay.
Collected from sources.
Yeah. So this was the first step. Yeah. So we sort of collected 1 million out of the database we had and said, okay, looked at this and said, Not great, but I mean, the structure is there. So then we redid the whole thing, but we trained on 37 million points. We got Jan Tau over there to say, okay, give us everything you have. And here's the result after 37 million training. I think that's pretty good. It's not that we have, and we're not at the stage where we can say we can give you perfect synthetic data, but it looks pretty good to me. You can see that it's on the roads. There are some cases we look it's a bit off, but I mean let's give it some time and we can actually do it better. You look concerned, Jesper. Am I over time? Okay. And here's some statistics. And when you look at the statistic, you can say, okay, so it looks good, but it's not really at the final stage yet, because we can see that the speed that we have is about twice the speed that we have in real life. So we still have to train it to really get them to squeeze closer to each other at once. But location-wise, of course, we can see that from the picture, it is actually pretty good. So the next step, I mean, if we now look at where are we today, well, we can generate these GPS traces. We need to work a little bit more to get the speed correct, but I'm pretty confident that that's about a week or two to get that. And then the next time, we are actually thinking we're going to look at generating fuel rate, because this was just GPS, but we have the data for the fuel rate. So we could just plug that in as one of the outputs. And that's one of the pictures that you have. And then also apply it to a new city. So we can, I don't know, Tranås, perhaps, is that too small? Or Mjölby. You could try with Mjölby. The problem is that there isn't that much data available for other municipalities, so you can check if you're correct. Having 5 years of data on about 20 buses is pretty unique of that traffic. And there are some questions, of course, left for us. I mean, can we generate all the CAN data? I said we had 100 signals. Some of them are copies of each other. So, but can we actually generate everything? You're going to see some examples of braking patterns, for instance. Would we be able to generate synthetically realistic braking patterns? I don't know, because that requires more knowledge about the road network. And then, of course, can we generate fault data? We have, as I said, several cases of faults, but still, if you have several cases of faults, some of them are not correct. We have like, I think 15 compressor replacements, of which I think 5 are correct. 10 of them are not, but there are psychological effects of repairs as well. And also the fact that if a customer is about to go into a new contract, where should that customer buy its buses? Maybe from the company that replaced the compressors. So they might not have been broken, but it was suitable to replace them. Sort of about the service records quality. And I think that's my actually final word on this. Yes, it is. So any questions on technical aspects of this? Jesper, you can do that in the coffee break as well. It was kind of an introduction to the data that you're actually going to see some examples from in the remaining demonstrations. 20 minutes.
That's great. Yeah, exactly. So it's like perfect. I don't know if there is a question or not. Also, both Denny and Jesper will be here till the end of the workshop, so we can ask the questions in this discussion session. I guess that will be possible. Thank you.